In this lesson, we'll be focusing on simplifying rational exponents. I'll be showing 4 different examples of how to simplify rational exponents. So the first one will be 12m to the power of 1 by 6. Now this is just a simple example. How would I simplify this expression? Now the first step is you want to look at your exponent. Well, in this case we have 1 by 6, and that's a fraction, and we'd rather have whole numbers. So what do we do in case of a fraction in the exponent? We would try and make it into a square root, into square root form. Basically, with just one simple step, all you have to remember is you take the denominator of, take denominator of exponent. Take denominator of exponent, and then you're basically just gonna bring it to the front of the. Square root. So essentially, this expression will just become 6 square root 12m. So as you can tell, this fraction went from being the denominator into being basically just the front of the root. Now that's just simple enough. That'll be the first example. Here's the second example. We'll just have 3 square root 12x cubed y8. So this is just a cube root, and within that cube root we have rational expression. So now the goal of this is to simplify this even further than it already is. Now what's the best way to do that? Basically, instead of making this look like it's a cube root, what we can do, and making it a little complex, basically we can just expand this. We can just expand this expression by a lot. So we'll keep the cube root, but we can expand what's inside of it. We can make this 12 x y y y y y y y y. Now this is valid because all this is that we basically just expanded the x's and the y's. It's the exact same expression. It's just that now we can take this and we look at what we're rooting by. So whatever we're rooting by. In this case, our root is 3. The root is 3. So what we'll do is we'll group these variables into groups of 3. We have 1, 2, 3 x's, so that works. All the x's are gone. Now, 1, 2, 3. 3 y's. And then 1, 2, 3. 3 y's. And then we have 2 y's, but we can't group them because we don't have one more y to make 3 y's, so we can't group that. Now, what we can do after this is we can essentially just take these groups and then we can just count off the groups. So once we've grouped them into groups of 3, what happens is they all can now come out of the cube root. And that is because, since it is a cube root, this 3 will cancel off these groups. And what's left is on the outside is 1 group of x and 2 groups of y, so xy squared. That being said, we can now create our second part of the equation, which will now look like xy squared cube root here. So xy squared, and so 3 cube root 12, and then we have that y squared left over that we could not group. Now, this will be our final answer. But let's just break this down one more time. We were able to get this xy squared because in this original equation, we basically just expanded everything. So x, y, so 8 of those y's. And then we just grouped them based on whatever number was here. And whatever number was here, so that was 3, so we made it into groups of 3, as many as we could until we had a remainder or none. It just depends. And then we took the amount of groups of that variable, and then we brought them outside of the cube root. And then, so we have 1 group of x, so that's where the x came from, and then 2 groups of y, so y squared, so y and y, so y squared. And then whatever we can't take out of it, so 12 and y squared, that just remains in it, and this would be our final answer. So our final answer is xy squared and then cube root of 12y squared. So that's just our second example. So, and here is our third example. So it's 8m cubed n squared k to the power of 2 by 3. Now this looks similar to our first example. And remember, what you have to do is you basically have to take the denominator and then we bring it to the outside here. So let's go ahead and write that down. We have our new equation would be 8 m cubed n squared k with a cube under a cube root. This is all to the power of 2. Because remember, only that denominator moves. The exponent, the numerator, does not move. So that remains to the power of 2. Now what should we do from here? Well, the most logical thing would be to just expand what's ever inside that cubic function. The cubic root. So we'll write this, and that means, so we'll expand this. So this will now become 64 m6 n to the power of 4 and k to the power of 2. Now that we've got here, what we can do is we can just do the same grouping thing as we did in the last example. So let's just expand this. 3 cubed. And this one we can break down the 64. So 64 is just 2 to the power of 3 times 2 to the power of 3. Because 2 to the power of 3 is 8, and 8 times 8 is 64. So we basically just adhered to the cubic root. Now 2 to the power of 3 times 2 to the power of 3 times m M, M. And that would be 6 times. And then 1, 2, 3, 4. And then K and K. Remember, this is just the expanded version, so nothing about our expression has changed so far. Now, once we get to this point, all we have to do is group it. So we can group these. We've got 1 and 2. And then we have, so now we have to do groups of 3. 1, 2, 3. 1, 2, 3. And then we have to do our N. 1, 2, 3. And then our K's don't work because there's only 2 of them. Now what we have to do is we have to take everything that we're able to group and we have to bring it outside of our equation. So we take all 5 of these groups and we bring them outside. Now what happens here? We get our new equation, which looks like, our new equation will look like 4. And now the reason there's a 4 is because this base of 2 does not change. So we just brought 2 times 2, or 2 squared, because there's 2 of them. That would equal 4. So 4, and then there's 1 group of M, 2 group of M, so M squared. There's one group of N, so N. Now there's nothing else here, so that means we can just do cube root of whatever we couldn't group. That would be a singular N, and then K squared. And that will be our final answer. So now we'll just recap. We brought the denominator. So we brought the denominator to the back here. And then we kept our numerator here. So now we've got this new equation. And then if we have this extra exponent, we distribute it. And then once you distribute it, if we can break down this extra value, in this case 64, if we can break it down so it can be taken out of the cube root or square root or just the root, that would be the best. That would be the best possible scenario. So you can take it out. If you can take it out, you should break it down. And then next you just expand everything into its singular variables. And then you group them depending on whatever number this is. And then once you've reached this point, you count up your groups and your variables, and then you decide what comes on the outside. And then whatever is left, you can just leave in the root. So that would be our third example. So here's our fourth example. We have 64 h to the power of 3, m to the power of 16, and n to the power of 9 to the root 4. Now this is using a little bit bigger exponents, but it can be solved just like our other problems. Now what we would do here is we would first expand this root. So you'd expand it. So this would become 4 root. So 64 is just 2 to the power of 4 times 2 to the power of 2. Because 2 to the power of 4 is, so 2 times 2 times 2 times 2, 4 times 4 equals 16. So 16 times 4 is 64. Makes sense. So 2 to the power of 4 times 2 to the power of 2. Now we have h to the power of 3, so we can just break this down into h times h times h. And then m to the power of 16. We don't have to write out all of 16. You can just do m to the power of 4, m to the power of 4, m to the power of 4, m to the power of 4. And then n. So there would be 9 in there. Yeah. So there's 9 in there. And also you could have written the n's like n to the power of 4 times n to the power of 4 times n. It just has to, all the exponents have to add up with the property of the exponents. They just have to add up to 9. And you don't have to write it out once you become comfortable. So now we can go ahead and group based on whatever number is here, and that would be 4. So we do it in groups of 4. So this works. H does not work, but we have these 4 work. And then 1, 2, 3, 4. 1, 2, 3, 4. And now we have that one n on the end. So now we can go ahead and just take these guys out of the root. And then so on. Now, let's find out our new equation. The new equation will be 4 we'll start off with what's outside. So we have 2 to the power of 4 taken out. So that'll just be the base. So that'll just be 1, 2. And now we have 4 sets of m's taken out. So m to the power of 4. 4 sets of them. And then 2 n's. So n to the power of 2. And now we have, that's on our outside. So now 4 root 4. So we have 2 to the power of 2 left, so that would be just 4. And h's, none of the h's got taken away, so h to the power of 3. And then our 1n on the end. So this would be our final answer. Thank you for watching this video. Be sure to like and subscribe and watch out for future videos. Thank you.